Hello, my name is Sanat Rao and this is my tryout for electric vehicle. So this is the main design for my tryout. So it'll be a 3D printed chassis, which I have right here. So there are holes cut out here for ball bearings to go into. Now the width of the ball bearings is approximately 22 millimeters in diameter. These separate legs are about 45 millimeters in diameter. The whole length is about 200 millimeter, which fits into the guidelines of the event. And it'll be propelled by an encoder motor positioned here, and that'll be controlled by an Arduino Mega attached to a rotary encoder, which will modulate distance. That distance will be displayed on a 7-segment display, and there'll be a 12-volt battery pack that is powering the whole operation, and an L298N motor driver will connect the Arduino Mega and the encoder motor to drive the motor. The motor will drive a belt drive mechanism that will drive the axles, which will be attached to the ball bearings. This is a rear profile of it, which shows that there are also gaskets in between the wheel and the axles, because what it'll be positioned as is as such. There will be a space in between the wheel attached at the end and the chassis, and therefore there will be gaskets or spacers needed in order to prevent the wheel or the axles from sliding around. In the top right, there's a diagram of the wheels. This is an example of one of the wheels. These have been 3D printed from ABS plastic. There will be a polyurethane coating on it in order to add friction to make the wheels accelerate the vehicle. The approximate cost of this build will be approximately $80 in addition to the current materials on hand. So this is itemized here in the materials. I'll need polyurethane sheets for the wheels, for the tires on the wheels. This can range anywhere from $25 to $40 depending on the vendor. This specific vendor lists it at $35. Wheels for the belt drive or the pulleys will be roughly $12 to $15. These will be 3D printed at the South County Regional Library. The ball bearings are about $10. This is on Amazon.com, and this is the link I plan to use. For this build, we will most likely use zip ties to ensure flexibility throughout the whole building process. A box of zip ties for this will cost roughly $12. The encoder motor, L298N motor driver, rotary encoder, 7-segment display, and Arduino Mega programming board are all on hand currently, and the circuit has been started building. The 3D printed materials will be detailed later. Wires and peripherals, wires meaning things that we can use to connect the circuit, and peripherals meaning like tape, glue, scissors, etc. And finally, a rubber band for the belt drive in order to actually drive the pulleys. So 3D printed materials. So the chassis, the axle, and the wheel are a few examples of such materials. So the components will be designed by me using Onshape CAD as a free online software on which I have an account, and they'll be printed at the South County Regional Library, which does cost money, though it is one of the most inexpensive and most efficient options for 3D printing. The chassis, wheel frames, and axles have all been currently printed as previously depicted. I plan to also design and print pulleys for the belt drive. They'll be shaped similar to a wheel, but instead of this flat edge over here, there'll be a little indentation for which the belt will go into. This is an approximate timeline of how our building process will go. So, we'll start roughly within 10 days of teams being released. The circuit will be finished as there's minimal things to be added, just the rotary encoder and the 7-segment display. Again, this will be shown later. October 27th, we plan to have all supplies bought and arrived, meaning all supplies like the ball bearings, the polyurethane, should be delivered by that point. November 3rd, we'll have the first draft of the build complete in time for Rickard Science Olympiad Invitational. By November 10th, all of our 3D printing will be complete, and hopefully we'll have it all in-house by that point. It, of course, also depends on South County Regional's timetable, but November 10th is the approximate deadline for these 3D printing. November 17th, we'll finish writing and annotating the code. This will be the code for running and tuning the device. Testing in the gym will start November 27th until January 5th, at which point we will reevaluate our strategy based on what has and hasn't worked, and we will reloop and set the plan forth going from there. Jan 12th, we will resume testing in the gym. This is the current progress. In the top right, you can see the image of my current circuit. There's an L298N, that's the red board, that is connected to a 12-volt battery pack in the Arduino. The Arduino is the blue board. The Arduino is connected to an encoder motor, which is on the far right of this slide. That encoder motor travels at, I believe, 600 RPM, and that will drive the motor. 600 RPM is the maximum. The current tested maximum is roughly 300 to 500. The rotary encoder, and the 7-segment display are depicted in this image, though they have not been connected to the circuit. The 3D printing for the chassis, wheel frames, and axles has been completed, and most of the peripherals are already on hand. Thank you!